Okay. So this will be similar to 5.1 and 5.2. Only difference is the angles are a little more difficult, and they're going to have us deal with tangent, secant, cosecant. Okay, so if you saw the other stuff, or if you remember it, you should be good. But let's get right to it, right? Let's refresh what we did in 5.1 and 2. Okay, where's that thing? Actually, I think it's better if I do this. All right, can you guys see that okay? So the trig function at an angle theta, so all these angles will be on the unit circle. So the coordinate, the endpoint of the unit circle, x value will refer to cosine. So if they ask for cosine of theta, they're asking you what is the x on the circle. That's it. If they say secant, well, that's just the reciprocal. So just flip the cosine over. So if this is like a 1/2, flip it over and get a 2, right? Take the reciprocal. For sine, if they ask for sine of some angle, that's the y value. Cosecant is its reciprocal of sine, so just flip that over. I'm sure you've already seen this in 5.1 and 5.2, just in case. Tangent is sine over cosine, y over x. So you can just take the y, x, divide it, simplify, and it'll be good. Okay. Cotangent, just flip over the tangent. But you can also think of it as cosine over sine or x over y. Doesn't matter. If you notice that one of these has a 0 on the bottom, you're going to have to write undefined. Okay, you can't divide by 0. So if that happens anywhere during your problems, just put undefined. And if you notice that the angle is not on the circle, then it might be too big. So you might have to find the coterminal angle by subtracting 360 or subtracting 2 pi, which I think you've already done a little bit, right? So let's just do that again. So I'm going to shorten that question. Find sine theta, cosine theta, tangent theta. Let's go ahead and find all of them. Cosecant theta. Given that theta was equal to, what was that first question? 9 pi fourths. This is question number 1 on your homework. So for step 1, find the coterminal angle. Of 9 pi fourths that is on your circle, your unit circle. Okay. Now, if you're not sure, I mean, first let's just look at the circle, right? If you look at it, is that better or worse? Better? If you look at your circle, and I'll switch back in just a moment. Is 9 pi fourths on there? I see a 7 pi fourths, right? It looks like it's going to be out here somewhere. So it goes all the way around and then keeps going, meaning it's too big. It's bigger than 1 revolution. So subtract 1 revolution. Okay, so there was some similar questions in 5.2, I think. So just go to 9 pi fourths and subtract 2 pi. Another way you can check if you can't see it by just looking at it, grab my calculator. What is 2 times pi? Right, 2 pi is like 360, right? And as a decimal, it's 6.28. It's about 6.3. So the angle that they're talking about, is that bigger than 6.2? Yeah, so right away you can tell, okay, yeah, it went too far. So I should subtract 2 pi, subtract one revolution. So to find the coterminal, just take 9 pi fourths, subtract 2 pi. That's it. If you prefer degrees, you can convert it and then subtract 360. That's fine. I'm not going to force you to do one way or the other, but you should be comfortable with fractions. Get the common denominator here. That would be multiply 4 over 4. That would be 8 pi over 4. So it's actually pi fourths. So it's in quadrant 1 at 45 degrees, basically. So the real question they're asking for, so just find the angle, the sine of 45, or we'll use pi fourths, that's fine. Sine of pi over 4, cosine of pi over 4, tangent of pi over 4. This will be the reciprocal of sine, we said is cosecant, right? So I'm just going to go put it over here. So I can just flip it over. Secant for cosine. Cotangent for tangent. So I like to put the reciprocals right next to it. That way I can just flip it over and not do any work. Okay. So go to your unit circle. Sine of pi over 4. It's going to be the y value right here. Right? It turns out they're both the same at that angle. So there we go. And if you divide the same thing, you're going to get a 1, right? I'll go ahead and show it, I guess. Now, once you have all those answers, just take the reciprocals, and you'll have the rest. Okay. So flip that over. Flip this over. If you flip over a 1, it's still a 1. I mean, technically that is correct, but we should rationalize. Right? We don't like having skirts on the bottom, but if you did this on the test, I wouldn't deduct points. I don't like it, but it's okay. The homework, though, might take points off. I'm not sure, actually. You'll have to let me know. It may accept both. Try on the glare, huh? So just to rationalize, you just multiply by root 2 over root 2, because this essentially squares the bottom. So you'll get 2 root 2 over 2, 2 root 2 over 2, which cancels the 2's. And those are all our answers right here. Okay. Any questions on example 1? Is that pretty straightforward? Okay. The first like 6 questions will be just like this. Just subtract by 2 pi if it's too big, and then find sine, cosine, tangent, etc. You switch back to the homework. So you just type it in here. Same thing for number 2 and 3. They should be pretty similar. If it doesn't change it, then it's okay. The point is that you practice on paper, though. Like make sure you work it out. because on the exams, I want to see your steps. Although there's not much to show for a question like this, because you're just writing it off the unit circle, but keep in mind you should practice not just punching in the answers. Okay, that's not going to help much when it comes to test time. You guys cool on this idea? You want to do one more of these, or does it make sense? Is there any questions on using the unit circle? All right, let's move to something different then. If you have an objection, please let me know. Doesn't bother me either way. Let's do the one that has negatives. Number 7. I'll leave the rest to you. 1 through 6 are very similar. You guys cool on this page? If I'm ever going too fast, let me know. If I make no sense, please tell me. I'm not gonna get upset. I think the record is like 6 times repeating myself on the same question. Yeah. Yeah, I'll try that. I will try. Yeah. I'm just gonna write this down here. Evaluate the following. Right, bigger. Okay. So sine of 3 pi fourths, part A. First thing is that on our circle? And that's good news then. It's an easy one. Is it the x or y value? So we write down the y. No big deal, right? Okay. And part B, cosine of negative 7 pi fourths. Okay. So if it's negative, I mean, you could just go to the negative direction, because we said in the video, right? Negative angle means you went negative direction. 7 pi fourths is right here. So 315 is the same thing. So if you went positive, it'd be starting here at 0 all the way down to 315. But if I go negative, it'd be this way. So technically, it's actually this answer for this location. But you can also just add 2 pi and fix the negative angle. Okay, I think that's the proper way. Let's do that. I'll do it over here. So negative 7 pi over 4 plus 2 pi. Make that better. Here. That too big? Okay. So same thing, get this common denominator here. So 4 over 4, that'll give us 8 pi over 4, which will become pi over 4. So this is a coterminal angle that we will use. So this is the same as cosine of pi over 4. Because pi over 4 is coterminal to negative 7 pi fourths. And all coterminal means is it's the same location represented by a different angle. That's it. Same thing. So cosine is the x value, right? So let's see. Pi over 4. Square root 2 over 2. Nothing crazy. Any questions so far? Yeah. Yeah, so if you add 2 pi to anything, you'll always end up at the same spot. It's basically adding 360. It's the same thing. But since I was negative, I figured, well, if I add 2 pi, it should correct the negative and give me a positive. If it's, yes.
Excellent. Positive, it's subtracting 2 pi, negative 10.
Yeah, if it's too big, subtract 2 pi. If it's bigger than 360 or bigger than 2 pi, subtract it. If it's negative, add. Okay, should work out. Sometimes you may have to do it multiple times if it's really large. Like if it was, I don't know, 930 degrees, you would subtract multiple times. That's a few circles, right? Almost 3 circles. Yeah. Put over. What was C? So we can just use the coterminal angle instead, right here. So tangent of pi root 4, that will be square root 2 over 2 divided by square root 2 over 2. Any question on number 7? That okay? Okay. I'll leave 4 to you. But yeah, the rest are pretty much the same. Maybe a little more complicated. Number 10, they're just trying to show you how these are reciprocals. So if you find tangent, cotangent just flipped over. That's it. There's no extra work here. Number 12, you'll have some that are undefined. So pay attention as to where the 0 is. Okay, if the 0 is in the denominator, then you should write undefined. 13 is a little different, but it's actually super easy. Instead of giving you an angle, they're telling you that that is the point, x and y. So I should switch direction, the camera thing, forgot. Need to switch, or otherwise I won't record what I've seen. So on 13, the x value negative 3/5 is actually the value that will correspond to cosine t. Negative 4/5 will be the sign. So the answer is really right here. There's nothing to do. Okay. So instead of being on the circle, it's right there. So sine, y value, cosine x value, tangent will be the y divided by x. Okay. I think I did that earlier. Does that make sense? So
For tangent, when you're like the y over x, you have to like x
yeah, you'll have to simplify it'll become 4/3, right? Because the negatives will cancel and the 5s will cancel. Okay, this is the same deal here. Oh, here we go. This is different. Let's do 18. So on 18, they say cosine is equal to 10 over 26. Oops. Try to zoom in. And theta is between 0 and pi over 2. So whenever you see this, in my head, when I see this, it just means that we're between 0 and pi over 2. That's it. So if we go to that location, we go 0 to pi over 2, it's basically telling us that we are in quadrant 1. Okay? So there's pi over 2, and there's 0. So we're in this location. Now, the other information was cosine is 10 over 26, which means that it's positive. So it's giving us hints, basically. Cosine is positive, and we're in quadrant 1. So what does that mean for everything else? Right? That means that everything will be positive, right? Because we're quadrant 1, tangent is positive, sine is positive, etc. So in these questions, what you're going to do is use those hints to figure out what the other functions will be using a formula. So when you're using that formula, you will need to choose a correct positive or negative. So that'll be up to you. Okay. But we can tell that's all going to be a positive. Let's see here. Let's go ahead and do it. 18. You guys cool on this page? All right, let me write the question down. So what I'd like you to do before class is just read over the section and write down all the formulas. And then in class, we'll show you how to do the problems. Okay? That way you have all your stuff with you. I'll try to send you some formula sheets too, but I think that'll be the best way to prepare. Oh man, I forgot the list. Okay. I guess we already have cosine, but oh well, who cares? They didn't ask for all this, but we're going to do it anyway, just for practice. We're going to find all 6 given this information. So one of the formulas that you need is the fact that sine squared theta plus cosine squared theta is equal to 1. The information they gave us means that theta is in quadrant 1. That's something you're going to have to figure out on your own. Use the hints to decide which quadrant, okay? Now plug in what they gave us and solve for sine. Once you have sine, you can figure out the rest. That's 676, right? 26 squared, is that right? 10 squared is 100. 26 squared is 676. So you're gonna have to isolate the sine squared and then square root both sides. But when you square root both sides, you have to tack on plus or minus. So you need to choose, is it plus or is it minus? And that's when this comes in handy, right? This tells you everything should be plus. So let's go ahead and do this. Subtract this over. 1 minus 100 over 676. Get the common denominator. That'll be 676 over 676. That's 100, right? Okay. So sine squared will be 576 over 676. If you square root both sides, tack on the plus or minus on the number part. So sine theta will be positive. Is that a perfect square? It is. Oops. Dyslexic there. 576. Yeah. So this will be positive 24 over 26. Since we did that earlier. 26. Okay. So we got sine. We got cosine. That was given to us. Right? Yeah. We should. Although they didn't reduce the original cosine they gave us. That's kind of weird. But it should all be reduced technically. This will be 12 over 13. This will be 5 over 13. Cosecant will be the reciprocal. Just flip it over. The reciprocal, right? Okay. And then tangent will be sine over cosine. So 12/13 divided by 5/13. So that's 12 over 5. And then the reciprocal, 5 over 12. Any questions on this example? So once we use the formula, you get sine and the rest just follows. Oh, wait a sec. Makes sense so far. It's not too bad. Okay. Well, that's it for 18. See what else we should look at. That's 18. 19 would be the same thing, but notice no, that's also quadrant 1. That's not interesting. 20 is different. Here they're telling us that cosine is negative, and that's kind of blurry for some reason. Tangent is also negative, so tangent less than 0, so the hints are tangent is negative and cosine is negative. So where does that where does both of those things happen? Which quadrant? Yeah, I think it has to be 3, right? Here all the x's are negative, but tangent would be positive, right? Because it'd be negative divided by negative. So yeah, it can't be 3. It has to be 2. Because they said tangent was negative, right? Yeah. So x is negative in quadrants 2 and 3, but tangent is negative only in 2 and 4. So it has to be 2. So once you decide which quadrant, you start using the formula to solve for sine, because they give you cosine. So just like the last example, it'd be exactly the same. Just choose the right signs. So, is there any questions about that? Can you figure out which quadrant? Same thing here. They give you cosine and some information. Oops. Here they give you tangent, but sine is negative, so you have to again decide which quadrant. Okay, so be comfortable with quadrants. I think that's pretty much it. There's some formulas you're going to need in the book, so please write those down. You're going to need the even and odd formulas, the formulas for an angle plus pi, and an angle plus pi over 2. So if you have those formulas down, these will be pretty easy. It'll be exactly the same as before with an extra step. Okay. Any questions on 5.3? That's everything.
So we can find those formulas.
Yeah, so you can use the link to get to the book, or you can go to Canvas and download the PDF I put in there. There's also the ebook in here somewhere. All right. Yeah, well, we'll stop here for today. You guys have any questions on 5.1 through 3? Is it okay? All right. If you have any concerns or questions, you're welcome to stay for a bit.
Where do we find the recording?
I'm gonna send you a link through Remind. So in Remind, you'll see the PDF and then the YouTube link.